Good morning, students. This is good afternoon. Today we are going to discuss relation between intensity and amplitude of a wave. What is a wave? Some disturbance which propagates from one place to another place. And that disturbance usually carries information. Information of what? Information that there is some change. So here some change happened and that change has to be transferred to the next point. Then that change has to be transferred to the next point. So for example, when I speak, I create some changes here. Changes in what? Pressure. When I don't speak, this air, see, I have to speak only, not to explain. So when I don't speak, this air will be at some pressure. The moment I speak, I create here compressions and rarefactions. And that is the change, the pressure changes which propagate from one region to another region. And that is called sound waves. So in any way, you have some disturbance. For example, in transverse wave, the particles will be disturbed perpendicular to the direction of propagation. Right? In transverse wave, if the propagation is this side, particles will be disturbed or particles will oscillate this way. In which way? No, in which way? In longitudinal wave, what will happen? If the wave is going this side, particles will have displacement this side. So here the displacement is perpendicular to propagation. Here the displacement is parallel to propagation. Now, let us say this line represents x-axis. For transverse wave, the displacement is along which axis? Y-axis. So here we will plot the displacement. And since it is a wave, the disturbance may look like this. If it is harmonic wave, that day I spoke about harmonic wave. But then there can be other waves also, I told. What was the formula for any kind of wave? Y as a function of x and t. It should be in the combination of what? X plus minus t. So this is actually a wave, mathematical function. But for harmonic function like sine function and cosine function, what was the formula? Y equal to a sine kx minus or plus omega. Correct or not? Now here you have to be slightly careful because in longitudinal wave the particle's displacement is along x-axis only. In transverse wave the displacement of the particle is along y-axis. Yes or no? So displacement we are plotting along y-axis and x represents what I told, position of the particle. Which particle are you talking about? So if you say particle at x equal to 0, it means which particle? This particle. If I choose origin here, then if I choose x equal to 0 particle, which particle I am talking about? This particle. X equals to 1 centimeter. From here go 1 centimeter. X equal to 10 centimeter. From here go 10 centimeter. So for this particle, what is the displacement? Displacement is measured where? Along y-axis. So we will plot displacement along y-axis and position along x-axis. So for this particle, what is the displacement? 0. Right now in this diagram. For this particle, what is the displacement? Maximum. Maximum displacement is called what I told? Amplitude. Problem with longitudinal wave. The displacement is also along x-axis. Yes or no? Now how will you plot the graph now? Suppose you want to show displacement of this particle, displacement of this particle. X represents position of the particle. Now displacement here is also along x, but graph we cannot draw along x, no. How can you draw two variables in the same axis? Then how will you understand how one changes with the other? Like in school days you may have done current voltage relation, Ohm's law. So current and voltage, suppose. Now current if you plot in this axis, voltage also you will plot in this axis only. Hello? Where will you plot voltage? In cricket, when they show runs with overs, if this line represents overs, this line represents run also. Runs where they will show here. So in this much over, this much runs. In this much over, this much runs. Correct or not? So, though the graph will have displacement here, but you have to understand in longitudinal way the displacement is along x-axis only. Understood? In graph we have to show along y-axis. Because two variables cannot be plotted on the same axis. So whether transverse way or longitudinal way, displacement of the particle at different position will be shown by similar graphs. Similar. If that equation is a sin kx minus omega t, this equation will be also a sin kx minus omega t. No difference. But in your head you have to remember that here the disturbance is perpendicular to the x-axis or wherever the particles are, and here the displacement is parallel to x-axis. Understood? Will you remember this? Okay. Now come to this intensity. When I was doing with you units and measurement, that time we wrote the dimensions of intensity. And to write dimensions of any quantity, what you should know? Formula for that quantity. So who remembers formula for intensity? So intensity's formula is what? Do you think it will be related to energy? Yes or no? Do you think intensity of a wave, intensity of sound, intensity of light, do you think it will be related to energy of the light, energy of the sound? Yes or no? Yes. Obviously sound, light, all are forms of energy. So intensity will be 100% related to energy. Now you only think 10 joules energy here, 10 joules energy here. Here the 10 joules energy is concentrated in this much space. So 10 joules is coming like this. Here 10 joules is coming like this. First 10 joules is coming like this. Second 10 joules is coming like this. Which one do you think is more intense? First one, where the energy is concentrated. So when energy is concentrated, we say it is intense. What? Intense. So area matters. What matters? Area. So if energy is flowing, you have to imagine some area perpendicular to the flow of energy. Perpendicular to the flow of energy. So energy per unit area. Why per unit area? Because smaller the area, more intense it will be. More intense. Clear? Time do you think matters? Suppose 10 joules comes in 1 second and 10 joules comes in 100 years. Very slowly. In one it comes fast. Which one will you think intense? Fast or when it comes slowly? Fast. So if time taken is less, intensity will be more. So this is how we define intensity of any wave. Energy per unit area per unit time. And the area should be held perpendicular to the flow of energy. Perpendicular. Understanding? Say the formula 5 times. So we'll give symbols to these quantities. For intensity I, for energy E, for area. Usually what we do, right? A. But here A we are using for amplitude. So we will use S. Why S? Surface area. Technique we use. Time taken is T. So this is intensity. Energy per unit area per unit time. Now what is energy of a single particle performing SHM? Energy of a single particle performing SHM. Half m omega square a square, where m represents mass of one particle. But when this energy is flowing through some area, let's say this is the area S. Through this area, your let's say wave is coming out. Radiation is coming out, sound, light, whatever, I don't care. So when this radiation is coming out from this area perpendicularly, in time t, this wave reaches let's say here, in time t. Now what is the distance covered? What is the speed of wave? V. So distance will be what? Speed into time. So in time t, this disturbance will reach here. Let us assume. Sir, why it reach only here? Why it can't go till here? It can go till there. Depends on what time you wait. So let's wait for t time. So in time t, this wave or this disturbance has reached here. In that time, this much energy will move, no? See, when I was teaching you equation of continuity, what I told you, imagine this is pipe, there is water inside. When this layer of water will reach here, this layer will reach here, no? This layer will reach here, right? And this layer will, that much will come out. So when this layer will reach here, distance covered will be what? Speed into time. Where here speed is the speed of the flow of the water. So in time t, if this layer reached here, this much volume crossed the pipe. Agreed or disagreed? If this layer reaches here, this layer will reach here, this layer will reach here, this layer will come out obviously. So if this layer reaches here, this layer will come out. So this much layer could have gone here. That means this much water will flow out. Understood? So in time t, if this disturbance or this wave reaches here, then this much energy has crossed. This much energy. Whatever energy is here in this volume. Now how to find that energy? Let us think. This formula is energy for one particle. In this volume, how many particles may be there? One or many? Many. So we need to multiply with number of particles. That will be energy of all the particles which are in this volume. So that will be equal to how much? Half. Now n into m. What will be what? If this is mass of one particle and you multiply with all the particles in this volume, total mass of this volume you will get. So this is mass of this volume into omega square is. So that would be the energy. Substitute the energy here. Now tell me intensity. So if you substitute this energy here which came from SHM. Now why we can use SHM formula? Because in waves particles are moving simple harmonically. Because we are considering harmonic waves. So substitute this energy here. So our intensity of the wave will be E is how much? Half m. Again I am telling you, this m I took as mass of one particle. This m represents mass of all the particles in this volume. in this volume into omega square A square divided by S into T. Now students, it is no use to write the formula of intensity in terms of mass. It is no use. When you say, why sir, what is the problem? Here too you wrote no sir, in terms of mass. Yeah, for one particle it makes sense. Because one particle's mass you should know whose energy you want. I am moving this chalk up and down. The formula of the energy of the chalk will obviously have mass of the chalk. But here wave is moving in a medium. What is moving in a medium? Wave. In time t, I told this part of the wave reaches here. Now tell me, is it compulsory it should reach here only, or it can go up to here also? It can go up to here depending on the speed. So the mass here will depend on the time t, right? Yes or no? So if I take 2 seconds, I may go from here to here. If she wants to take 5 seconds, the wave may go from here to here. She will have more mass in that volume. If he says, sir, I want to wait for 1 minute, 60 seconds, then wave will go from here to more far it will go. So more mass will be there in that big volume, yes or no? So this mass is something which changes depending on time. Therefore, we don't want to write in terms of mass. We want to write something which is in terms of medium. Now tell me, what characteristic, which physical quantity determines which medium it is? Mediums are usually characterized by which physical quantity? Density. So we want to write in terms of density, because density though it is same. Air density will be 1.293, water's density will be 1000 kg per meter cube. Whether you take mass of water in bucket or mass of water in spoon or mass of water in swimming pool, if it is water, density will be same. The exact volume doesn't matter. Understood? So we want to write this formula in terms of density, because density is what dependent? Medium dependent. So how to write in terms of density? Mass is what? Density into volume. What is volume of this region? Remember, this area is S, I told. This area is S. And this distance is V into T. So this area is S. This distance is V into T. So what will be volume of this part? S into V into T. What formula? Length into breadth into height. Length into breadth matlab area, and here height matlab this distance which was covered in time t, and in time t what distance you covered? Speed into time. So this density, this mass is, so this mass is density into volume. What is volume of this we found? Area into distance. What is distance? Speed into t. Omega square A square by S into T. What happens to S? Cancels. Hey, this is cancel, okay, not dollar sign. And what happens to T? Cancel. So what is intensity of a wave? R rho V omega square A square. Write fast. Everyone tell me the formula for intensity of a wave in terms of amplitude. Fast. Half rho V omega square A square. Now most students what they do, they memorize intensity is proportional to square of amplitude. But I have told you many times, if y is proportional to x, check other things are constant. Who knows, frequency may also change. Not only the amplitude may change, the frequency also may change. So if frequency changes, this omega will change, because omega is angular frequency 2 pi L. So don't blindly think this is proportional to this all the time. Yes, if this is constant, this is constant, this is constant, then intensity is proportional to square of amplitude. Otherwise, you have to also say intensity is proportional to square of angular frequency. If what is constant now? Density and speed. Now these two are what dependent? Medium dependent. Medium dependent. If medium is same, these two will be same. Let's do one problem based on this. So consider this is y and this is time. Because in waves the disturbances change with not only position but also with time. So if you look at any one particle, the displacement of that particle changes with time. No, right now it is here, right now it is here, right now it is here. So see, it is changing with what? Time. In waves. So in waves displacement changes with time as well as with position. As well as with time. So I told just now. So as well as with position it changes. Okay. That's why we write formula for displacement as what? X comma t. What does x comma t means? The displacement changes with position as well as time. So here they have given you displacement versus time graph. For one way it looks like this. This is for one way. For another way it looks like this. This amplitude is A, this amplitude is 3A. This is for the first way, this is for the second way. You have to find ratio of intensity of the two waves. So this ratio you have to calculate for these two waves. What will be the ratio of intensity? You have to take density and speed as constant. Meaning you have to imagine both the waves are traveling in same medium. So density and speed will be same. Okay, try once. 1:9. No, then you took care of only amplitude. That is what I told. Did you check frequency is same? So, if you look at the formula and tell me amplitude of the first wave. First wave is the big one, no? What's the amplitude? 3A. Amplitude of second wave? A. So amplitude we know. Now do you think frequency is same? Look at the oscillations. Do you think frequency is same? No, frequency means number of oscillations. And if the oscillations are near, frequency will be more. If the oscillations are far, frequency will be less in time if the oscillations are far. For the big wave, this is time period because after that it repeats. For second wave, check the time period of second wave. How much? T or half of T? Half of T. This is the time period of second one. That means if time period is half, frequency will be what? Double. Because frequency and time period are inversely proportional. So if I say this has frequency f, the big wave, the small wave will have frequency 2f. Now 1 is for whom? 1 is for big wave or small wave? Big wave. So for big wave, what is frequency? F. So for small wave, what is frequency? 2f. That also we have to check. So intensity will be proportional to omega square a square. Don't only write intensity is proportional to a square because here frequency is also different. Understood? So what will be I1 by I2? Omega 1 by omega 2 square, A1 by A2 square. Correct? Now tell me when I wrote equal to, why these constants I did not write? Actually in the formula of intensity these three are also there, no? Why I did not write in the ratio? They will cancel if you write also because they are constant. That's why we don't write constants in ratio because they will cancel. Now what is omega 1, omega 2? That they have not given. They have given frequency. But omega formula you know 2 pi f1, 2 pi f2. Yes or no? A1 by A2 whole square. 2 pi cancel. If frequency of the first one is f, for second one is 2f. If amplitude of the first wave is 3a, second wave amplitude is a. Answer is 9:4. Everybody understood? F cancel, A cancel. 1 by 2 square, 1 by 4, 3 square, 9.